Memory areas. In Java, we have two memory areas. These memory areas are different because Java decides where to store different data from the program. Depending on the use of this data, Java heap space is used by Java runtime to allocate memory from objects and classes that they need to load, to compile, and to instantiate the objects. Garbage collection routes memory to free the memory used by objects that don't have any reference. Remember, you have to unreference objects, then the garbage collector can recollect these objects and eliminate them. Any object created in this space has global access and can be referenced from anywhere of the application. This means that you have any object created in the Java heap space object, not primitive. Primitive data is stored in another area. The Java stack memory is used for execution of the main thread. When you run a program in Java, you have to begin in a class in the main method and create a thread execution, the main thread execution. This contains the value that initiates that you have to run in the program. And it has a different variables, short-lived variables, and it references all objects in the heap. If you create a variable in your execution local thread, you have a reference in the Java stack memory and you have a reference in the heap space. Then you have to get in only the reference. The object is not in the Java stack memory. It is located in the heap space. If you are creating primitive types, it is the Java stack memory. Okay. Java stack memory is always referenced in LIFO. That means the last in, first out. If you create a primitive object in the Java stack memory, and it was the last object that was created, it will be the first out, in this order created. When the main method is finished, all the stack memory is clean. As you see in this image, we can see the areas in the heap space. You can see how it is divided in two main areas, the heap space in the green and blue spaces in the picture, and the permgem, permanent generation, spaces. The permgem spaces is a place where Java is loading all the classes that you need to instantiate. Then, if you need 1,000 classes we will store in this space. That is the problem when you get a permgem space error. The problem is the space is small and you are loading a lot of classes. Maybe you have to review if you are loading the right number of classes. Maybe you are loading a lot of classes that you don't need. Or maybe you have to increase the size of this space. In the other side, we have the heap space. The heap space has two areas, the young and the tenured areas. The young area is composed by three parts. The Eden is a place where you put the new objects. Just an instantiated object is placed in the Eden area. It lives there until the Java's collector runs and it says, oh, it's an object. Is it unreferenced? No. Okay, we have to put it in the first place of the survival area. If the garbage collector runs again and sees the object is referenced again, then takes this object, quits from the first area of the survival, and then puts it in the second area. What happens after if the object is not referenced anymore? The object is eliminated from the heap space area. Then, if the object is referenced already, then it puts the object in the tenured area and eliminates it out of the previous area. This will happen all the time Java's collector runs every any 1,000 seconds. Remember, it is a parallel program that is running in the Java virtual machine. Then they need to study what is the reference to the object. Maybe they have to destroy it or eliminate it. Maybe they have to pass the object from the Eden, where it has created, to the survivor area 1 or survivor area 2, to tenured area. What is the problem? When you are running the program and Java collector cannot eliminate a lot of objects in a tenured area, they have to stop the program and execute the name full garbage collect. The full garbage collect is a process where Java says, oh, there is a problem. I don't have any more memory to use, and I have to analyze all objects, analyze all reference to the objects, and maybe I can detect some unreferenced object that can be eliminated. Then the program stops. Maybe your program is in a freeze mode. Then you have to resolve this. If you are using your program and the full garbage collect begins, then you have to stop. And the full garbage collect ends. Then you have to wait. Maybe they cannot do the process. They cannot eliminate a lot of objects. The memory is full and we have an out of memory error. The program will end because you don't have any capability to create new objects. Then all areas full. That is the distribution of the memory areas of the Java heap space. What is the difference between heap space and stack space? Heap space is used by all the parts of the application. Whatever stack memory uses only by thread of execution. All objects are in the heap space. Local variables or primitive or local variable and methods are stored in the stack memory. Whenever an object is created, it is always stored in the heap space. Then the garbage collector will see if they have reference or not to another object. In the stack memory, it's not like that because these are in the area until the methods end, the principal execution thread. Stack memory only contains variables and reference variables to objects in heap space. They don't have any object that is stored in the heap space located in the stack memory. Objects stored in the heap are globally accessible since any time the stack memory can be accessed by another thread. Memory management in stack is done in LIFO. Remember, last in, first out? Stack memory is a short-lived whatever heap memory. It lives from the start until the end of the application execution. In other words, if you need more space to store objects that are operating in different programs, you have to increase the heap memory space. But if you are doing a lot of things in the main execution thread, you have to increase the memory stack. Because if you don't, you will have a stack overflow error. That's why it is important to distinguish between the out of memory error, because you don't have space in the heap space, and a stack overflow error, which means you don't have the space in the stack memory area. We have to analyze this more specifically in the next exercise.